So under this recording, I'll be explaining the concept of what matrices, right? Matrices. So I'll be explaining different parts. So let's start with discussing using a matrix. mm, in a row echelon form and also in reduced row echelon form. So let's start with the ones for row echelon form. Let's say you're given these matrices. So the very same matrix, we're going to reduce it into row echelon form and then into reduced echelon form. So you can also do other examples. So let's say they give you this matrix and say reduce the following into reduced uh, echelon form. So you're gonna start from row two because you already have a leading one on row one. So this is what you will do. So you'll come and say on one. So you'll start at row two. It means at row two you will say you are going to say row two minus, because you want to have zeros here. You will start by saying row two minus twice row one. If you do that, you are going to have 0, negative 1, negative 1, negative 1, negative, okay, negative 1. No, this one it won't be negative 1. So it will be 2 minus 2, 2 minus 2, 1. Uh, so it will be 0, this one. It will be 0. Then this one will be negative 2. 4 minus 2, 3. Yeah, it will be negative 2. And then we'll go to row 3. So you must change all this into 0. So you'll say on row 1, you'll say on row 3, we're going to say row 3 minus row 1. So you'll have 0 minus 2 minus 2, 0, 0, 2. Then here on this one, 1 minus 1, 0, negative 1, negative 1, negative 1. This one will be 0, 0, 0, 0, and then 1. This is when we say row 4 minus row 1. So now we're still changing to reduced echelon form. So in reduced echelon form, you just have to know that you must have leading ones on every column. Okay, and then for now we have zeros below, so we're fine. And then we're going to multiply this row by negative 1. So if we do that, it means we'll have 1, 1, 3, 4, 5. So we're going to multiply row 2 by negative 1. It means we'll have 0 and positive 2. Then we leave these ones as they are. Negative 1. So from here, what we are going to do is we'll change this one. We'll change this row. We want to have a leading one. See, we have got this. So we want to have a leading one there. So we'll multiply by what? By 1/2. And multiply by 1/2. Or we can just use the other rows to change. But let me use this easiest method. So we'll multiply by, on row 3, we'll multiply by 1/2. By -1/2, we have 0, 1, 1, 0, 0, -1. So now what? Now we're going to change. So now we're leading one there on row 3, which is this one. Then here we're still having this. And let me scroll. Then to change, then now we've got these ones, right? These leading ones. So the only thing left is for us to have zeros below, right? On our denominator, on our last column. So the last column, the last row, you must have zeros. One of the rules. So we're going to add, can just add row 3 with row 4. One, 1, 0, 0, -1. So we'll add these two rows. So we'll have 0, 0, 0, 0, 0, 1. That's what we'll have, right? So below there, again, once we must have what? We must have zeros. So we must change this one to be a 0. Then we'll be done. So it means we're going to subtract uh, 1. Means when we come to row number 3, row number 3 is the one that we must change. 1, 1, 1, 0, 2. On row 3, we're going to subtract with row 2. So you'll have 0, 0, 0, 0, 0, -3, right? Then the rest you leave it like this. So this will be our final answer for reduced echelon form. Below leading ones, below the leading ones, you have got zeros, right? So this is in reduced echelon form, and on every column you've got a leading one. So when you come to reduced row echelon form, you must just make sure that above the leading ones, they are what? They are zeros. On every column whereby you've got a leading one, you must have zeros above them. So this is what we'll do. 1, 2, 3, 4, 5. 3, 0. So it means here we're going to change. We can change this one. We must change this one to be a 0, right? So it means we're going to manipulate the first row. It will be row 1 minus row 2. So you'll have 1, 0, 0, 0, 1, 1. That's what we're going to have. And then we'll have 0, 1, 1, 1, 0, 2. Then we have 0, 0, 0, 0, 0, negative 3. And 0, 0, 0, 1. So the on this row was sorted. Then you'll also have to change which row has got a leading 1. Yeah, I think everything is fine. Let me see if we are leaving anything. Oh, this one. We'll have to also manipulate these values, right? We'll have to manipulate those ones. 1, 2, and negative 3. Mm. 1, 2, 3. So from here, we want to have a what zeros above this leading 1. Since we're having a leading 1 here. So what I'm going to do, we're going to change row number 2 by saying row 2 minus twice row 1. We just want to have a 0 there. So it will be 0, negative 1, negative 1, negative 1, 0, 0. And then now we'll have what? And then on row 3, we'll just say row 3 plus 3 row 1. So it will be 0, 0, 0, 0, 0, 0. And then, yeah, that's it. And then we write the last column as it was. So the idea is just to make sure that you've got what leading ones above, you have got zeros above the leading one. Then the last one to change will be this one up there. So is there a way to make it 0? So we'll just say row 1 minus row 4. So everything will be fine. This will be 0. The last step will be to multiply row number 2 by negative 1. So the last step will be to multiply this row by negative 1. Yeah, so this will be in reduced row echelon form. Reason being we're having zeros on the last row and we've got zeros above every leading one and below it and below them. So yeah, then we'll go to let me see what we can do now. We change this template. So now let's go to finding the determinant, right, of matrices. Finding the determinant. So I'm gonna start with a 2 by 2 matrix. For a 2 by 2 matrix, this is how you will find the determinant always. Let's say you are having the matrix -1, 2, 3, 3, 3. So what you have to do, you have to interchange these, right? To find the determinant, you'll interchange those. Or before you write the determinant, so it will be A equal to 3, -1, and then you change the signs. This is plus and minus, you plus and plus and plus. So the signs will remain the same because it's plus and plus. So they are not gonna have a problem, right? Let me check the one whereby we are having a negative. Mm, So yeah, what you have to know is that you must interchange. You must interchange this and this. Yeah, and then you'll have this, and then you also interchange the signs. If the signs are the same, it means it will remain the same. Then after you calculate the determinant, this will be like this. So I'll also do another example whereby the signs are different. Then this will be negative what 9. Then let's say you were having a matrix V, which is spelled 2 by 2. You find that you are having 4, -2, 3, 10. So it means your B was going to be 10, 4. Then you interchange the signs, you'll have -3, 2. Then you'll have your determinant to be like this. And then you just have to calculate this. Then this is 40 minus -6, which is simply 46. So now, if you're finding the determinant of, there is what we call Laplace expansion. This one is used if you want to find the determinant. It's a method, right? It's another method for finding the determinant. This one, for finding the determinant of any m by n matrix. Then we've got what we call Serra's scheme. This one is a method. It's another method for finding the determinant, and then it's only applicable on a 3 by 3 matrix. So now I'll start with Laplace. Laplace expansion. Let me see on your guide if they give an example. Yes. Under Laplace expansion. Uh, Yeah, so let's say they give you this matrix A, -2, 3, -1, 4, -7, 1, 1, 2, -5. So if you are to find the determinant of A, it's either write this or you write this. You will say the determinant, you put this, then from here, what you are going to do is you're going to choose where you are expanding. It's either you expand along columns or rows. But usually I prefer people to expand along rows. It usually is, or where you will see a 0. So now I'll expand my matrix along row what? Let's say we choose row 2. So you're going to, meaning that it will be this row. So you'll start with 4. And remember this one is row 1, it's row 1, column 1, 1, 2, A1, 3, A2, 1, A2, 3, A2, 2, 3, A3, 1, A3, 2, A3, 3. So where you see odd numbers, you are going to have negative. Yet, if you add this and you get odd numbers, you'll say it's negative, such as this one. A21 is an odd number, so it's negative, positive, negative, positive, negative, positive. So if we're expanding along this row, you're going to focus on these values for the determinant of A will simply be 4, and then you close this part and this part. Then you'll be left with what? No, I'm using the wrong part there. So you'll close this part and this part, and it's negative. So you'll start with -4 into, and let me use the highlight. You'll close this part and this part. No, so yeah, you will make a mistake again. You close those two left if you are expanding along road. Then now you will have 3 multiplied by -5, and then plus, then we move to -7. And if when you're on -7, you'll close here and there. Meaning now you'll be left with what? With -2 times -5 plus, and then the last value is 1, it will be negative. So you'll have -1 into, then you close, then you'll close this and this part. Then you'll be left with 2, 3, 1, 2. It will be -2, 3, 1, 2. -2 times 2 minus 1 times 3. Yeah, and then if you solve this, we should get -18. Let me just confirm what we're getting here. and 3. So here you'll get, I'm getting negative 17, and I think we're supposed to get negative 18. I don't know if maybe I'm punching the calculator wrong, but you guys will also confirm with this one. I may not spend more time on this. I think you already know these things. And then let me go to Sarah's team. Or let's also check if we're expanding along row 1, what we're going to get. I think it was better if I also showed how I'm actually doing this. Yeah, let me do it like this. Negative 4, then I'll be left with negative 2, 1. Oh, this will not be, it's not supposed to be negative. Let me see. No, yeah, it's supposed to be negative. What is 2, 1? 1, 2. Hmm. And this will be 3. Oh yeah, I made a mistake on the first one. Now I see. Then plus negative 7, 4, 1, 1, negative 5, plus, I'm still expanding along row 1, plus, so for this one, we close here and here, you'll be left with negative 2, negative 2, 3, 1, 2. Yeah, and then you do your workout. Negative 20 minus 1 plus 1 into negative 4 minus 3. So this will give you negative 18. And then let me go to Sarah's scheme. So on Sarah's scheme, I said you only apply it when you have got a 3 by 3 matrix. For an example, let's say you are given this. The variance, just take the variance matrix. We named it the A, right? This matrix was A. Let me copy it. Let's do this. We have this matrix is a 3 by 3. So applying Sarah's scheme. So it's always better to use this method, as is the easiest. So what you do, you just repeat the first column and the second column. These two, you repeat them. Then when you're done, you create a butterfly. You do this. Then you also create it on this part. And that's it. So let me just write whatever will be here. So you have A equal to . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . determinant of A will be equal to -2 times -7 times -5. So you start with the ones I highlighted in black, right? Then you add them. And then now you subtract the ones in blue. It will be -1 times -7 times -1 plus 2 times 1 times -2 plus -5 or 3. So yeah, and then you calculate. So yeah, let me see what you're gonna get. -75 minus -57. So you'll get -80. So you see that both methods they work, but then if it's a 3 by 3, you always use this one. So on a place, so this one you use it even if you have got a 4 by 4, a 5 by 5 matrix, 6 by 6, 5 by 7, any type of a matrix. So now let's go to, okay, with the properties of determinants, I'm sure you still know them, right? I can just write them for you. Properties of determinants. The first one says the sign of a determinant changes if any two rows or columns are interchanged. The sign of a determinant changes if any two columns or rows. If we interchange rows or columns, the sign will change. For an example, we're having this matrix 1, 2, -5. The determinant was -18. Now, if I decide to interchange this row and also interchange with this one, so meaning that I'll be having this then the sign will become +18, right? So that's one of the properties. So the determinant with a 0 column or 0 row is equal to 0. Okay, if you are having a matrix, so the determinant of a matrix with a what? With a 0 column or row. So any matrix that has got zeros either here or on this row, its determinant is going to be what? The determinant of this is going to give us 0. Then now go to the third one. If any two columns are equal, this determinant is equal to 0. But most of these things are not going to ask. Let me write the ones that determinant of AB. This is equivalent to the determinant of A multiplied by the determinant of B. And the determinant of A plus B, just know that this won't be the same as when you have the determinant of A plus determinant of B. The determinant of A will always be equal to the determinant of its transpose. The determinant of the inverse will be 1 over the determinant of A. So this one is it's very important. Then number 6, yeah, I think that's it. And then now let's do the Gauss-Jordan, right? Let's do the Gauss-Jordan. Elimination method. So this one is the one whereby you will have to make sure you are having, if you are having a matrix A, you are going to manipulate it, meaning you'll be having a matrix A, then you will say AI, which is the identity. So when you want to find its inverse, so now we're doing the inverse of matrices. So the inverse, if you're using this method, just know that the answer must be like this. You must have your identity on the left. An example is this one. Given A, -2, 3, 4, -5, then you'll just write this in this format. One zero zero one. So now from here, you'll make sure here you try to get your leading one. So meaning this row we don't know anything. Means it will be row, I can say row. Okay, we can try to first make this one to be 0 so that you can make things easy. The second row, because to change this one to a 1, it means you'll have to divide. So we want to try to avoid dividing. So it means we can come and say row 2 plus twice row 1. So it will be 4 plus 2 times 15. So this will be 0, 1, and then you'll get 2, 1. And that will remain the same. Then we'll go to the next part. So now you want to get another 0 here. So once you have put 0 and 0 here, it will make it easy to change this one to a 1. So you're going to say row 1 minus row plus 3 times row 2. Then this one will become 0. This one will become what? -5, -3. Then here you still have 1, 1, 0. Then this one will be -2 minus 3, 0 to remain the same. It will still be -2. Then from here, we want to ensure that we get a leading one, so we're forced to divide. Okay. So even up there, we could have divided, so I was avoiding opening the fractions. So divide by -1/2. So you'll end up having this. So this is our identity. Then this one is our inverse. So we've managed to change this. So this was for a 2 by 2 matrix, and that goes to then. Then when you are having a 3 by 3, the aim is still to change this to this, right? But then if it's a 3 by 3, it means your identity will change. Identity matrix must also be 3 by 3 in order for it to multiply. So meaning that you're going to get on the what? Yeah, meaning that you will start like this, right? So this one I'll leave it is there on your guide. Even that one is there. I'll just showing you how you actually do it. So now let me move to an example whereby you had to solve something interesting. So I have this question. They were saying solve for x, y, z using. So now I'm skipping, right? Using the inverse method, but this one now is another. Okay, let me see how I can actually introduce this quick. So this falls under. Okay, let me see. System of linear equations when you have to calculate unknowns. So, but after goes Jordan, what do we have on your side? You are having. Okay, you have got the adjoint method, né? Okay, yeah. Let me do the adjoint method. With this one, if you are looking for an identity of a matrix, if you are looking for the inverse, so the inverse on adjoint method will be equivalent to 1 over the determinant of your matrix, the adjoint of your matrix will be like this. The only problem that you will face is to get the adjoint of A. So, but it's not a problem. To get this, it's easy, right? So let's say you're having the very same matrix. What is it? 27114 negative 1130. Its determinant we already have it. It is equal to negative 2. We have managed to find it. So the problem will be to find the adjoint. So this is how you find the adjoint. So the adjoint of the matrix A is equal to the coefficient transpose. The question now is how do you get this C, the cofactors of our matrix. So this is what you do. You are having a matrix 27114 So C will be equivalent to. So for each value, you are going to do its cofactor. For each value, you must find the cofactor. So, but you don't write the cofactors, right? You exclude them. You just write the cofactors. The factors you don't write them. Right? Meaning for the first one you'll close this part and this part. You'll be left with what 4 negative 1 0, and this is positive. This is negative positive negative positive negative positive negative positive, and this will be negative for the second one 7. So I would close here and here. So meaning we'll be left with what? With 1, 1 negative 1, 1 negative 1, and 1 and 0. So that's it. That's how you actually do it. So for the rest, let me just write them. For this one, we need positive. Then you'll find the determinants of all those cofactors. This one will be negative, this one will be positive. Mm, okay, let me write the values. 7130, 2110, 2713, 714, negative 1, 211, negative 1. So these are the factors that you will find. I have shown you how to close and find those. So now you will find the determinants. So the cofactor, remember, the cofactor transpose will give us the adjoint. So the aim is to actually get there. So if you do the determinants of all of them, right? So we're still finding C. You'll get 3, negative 1, negative 1, 3, negative 1, 1, negative 11, 3, 1. Then you do the transpose. When you transpose, you interchange rows, columns with the rows, right? So you'll have on the first row, you'll have 3, 3, negative 11. Now you'll have negative 1, negative 1, 3. You'll have, then you'll have negative 1, 1, 1. So this is our adjoint of A. Now you do your B. So you know that the inverse is equal to 1 over the determinant of A, the adjoint of A. Then you'll have this. Yeah? And then from here, you'll just multiply by this negative half on every end. Then this will become positive. Positive half, negative half, negative half. So this will be our inverse matrix. To check if this is correct, if you multiply the inverse with A, with the matrix, you should get the identity matrix. Since this is a 3 by 3, you should get this 0, 0. It's supposed to be what? This one is 0, 1, 1, 0, 0. You must get something, you must get this identity matrix. So now let me move to system of linear equations. So given this question, let me just wait, and then I will end with this question for now. Solve for x, y, z using the inverse method. So on system of linear equations, this topic is based on finding the unknowns. So you cannot find the unknowns if you don't know the conditions, right? Solve for x, y, and z using the inverse method. Using the inverse method. So they will give you expressions, equations, right? So you'll have to change them into invertible matrices. 4, 5, x plus 8, 1. Now, let's say they give you something like that. It means you're going to have to change this and this one. So we can let this one be A, this one be B. So you're going to have 125 389. So in order for us to solve for a for xyz, let me write the equation that you must use here. So you must write this to be a in the form of ax equal to b. So meaning you'll have 1, 2, 5, 2, 3, 8, 3, 8, 9. Our x will be x, y, z. And then here you still have this. So in order to get these unknowns, it means you must make this one subject of the formula, right? If you take this one to the right, it will become the inverse. So it will be A inverse B. So now we know we're just going to have this matrix 1, 2, 3, 2. No, we'll just have x, y, z, which is our x, then the inverse. So the first thing you'll do is to find the inverse of this. So how do we find the inverse? This question it usually has 9 marks. So you must first find the inverse before you can actually, you know that it will be the inverse and then the b. Our b it's what? It's 3, 4, 11. Then let's try to get the inverse of this matrix. A inverse. So it's either will you decide to use the adjoint method, or you use the what? The Gauss-Jordan elimination. So I'm gonna choose the Gauss-Jordan elimination, because this one is easier, right? You don't have to do any cofactors. So meaning you will have a I, you change this to IA. That's all you must do. So we're going to have 1, 2, 3, 2, 3, 8, 5, 8, 9, 1, 0, 1, 0, 0. Remember that this must be diagonal left. Then we are having that. So now the aim is to convert this into IA, right? So the first thing, the first column is sorted. You will have to change this one and change this 2 to 0. You will say row 2 minus 2 row 1. You will have 0, negative 1, 2, so minus 2 times 1. This will be negative 2, 1, negative 2. Then to change the last one, you must also change this to 0. You'll say row 3 minus 5 row 1. So this one will be 0, negative 2, negative 6, and then this one will be negative 5. And then to get the next one, even this one will be negative 5. 1 minus 5 times 0, this will be 1. So the next thing is to change what I was supposed to change is to change this one to 0. So you'll just add row 1 with row 2 with row 3. Yes, with row 3. So if we do that here, you'll have 1 0. Let me say row 3. 3 plus negative 6, negative 3, negative 5, 0 plus 1 is 1. Then this one will leave it as it is for now. Then you're left with this column. Okay, so for with this one, you must change this one to 0, right? Yes, you must change it to 0. So you'll add row 3 with row 1 as well. This will be no, you let's add it like this because we don't want to change the value of that one. We'll say row 3 plus 2 row 2 row 2. No, it should be minus 2 row 2. And this will be 0. This will be 0. Negative 6 minus 2, 2. Negative 10. Negative 1. Negative 7. Then 5. So now the which now is to change these two to be zeros. So let's go to row 1 again. So now in order to change row 1, negative 3 to 0, you'll do what? Okay, here you'll be forced to say row 3, row 1 plus and 2 over 3 row 2. Let me confirm this. 3 over 2. 3 over 2 row 2. It should be minus. No, it will be negative 3 row 2. Yes, so this will be row 3, row 1 minus 3 negative what? 3 over 2 row 2. And let's see plus. Or let's just say plus here. Avoid confusion. And this will be remain 1. Then this one will be what? This will remain 0. This will be 0. Then will be this one. This one will be negative 7. Negative 7 over 2. Then negative 2. And this is 0. So now I want to change this 2 to 0. So we can do what? We can say row 2 minus row 3. Let's see. 2 minus 5. Negative 10 divided by 2, 5. Okay, 2 over 10. Plus, yeah, we'll just add that. So you'll have, this will remain what? Negative 1. Then this will be 0. Negative 2 plus 2 over 10 into negative 1. This will be negative 11 over 5. 1 plus 2 over 10. R3 is negative 7. This will be negative 2 over 5. So you must be careful when doing this. No? You can make mistakes, so rather not hurry, especially in the exam. Then this is negative 1. And this is still, this one will remain like this. Oh, we must change this negative 10 to 1. So I'll just divide everywhere by what? By negative 10. So that I can just have that 1. So this will be negative 0.03 multiplied by 1 over 10. This will be negative 1 over 10. Sorry, this will just be 1. And this will be 1 over 10, 7 over 10, 5 over 10, 5 over 10, which is 1 over 2. Now, this is our inverse matrix. I just have to multiply the second row with negative, and then that's it. Row 2 minus multiply by negative 1. Row 0, 1, 1 over 10, 7 over 10, 1 over 2. You see, so this is our inverse matrix. So let me copy it so that we can use it. So now we can put it here. So that's our inverse matrix. And then in order to solve for those values for x, y, and z, each, you just multiply these things. So yeah, this is what you will do if you are doing the inverse methods. X, Y, Z. You are going to have, for the first row, it will be negative 7 times 3 times 4 times 11. So that will be the first, for the first entry. One over 10, this is 10. Plus 7 over 10, 4, plus 1 over 2, 11. So let me see what we're getting. So your matrix will just be x, y, z. So whatever values you get here will be the value of x, y, z. I'm getting negative 57 for the first one. The second one, I'm getting 96 over 5. Over 10. Then for the second entry, we're getting 43 over 5. I don't know if maybe we made a mistake. You guys will try to check, but this is the procedure. 43 over 5, which is 8.6. One is 19.2. Okay, so yeah, those are the values of x, y, z. So the things that we'll be doing on the next recording are these ones. We'll do Cramer's rule. This one, it helps us to get what the values of x, y, z as well. This one is the easiest. And then we'll also do Ghost Jordan. Elimination. In order to find what the values of k, usually they use the letter k. And then we must also look at what's an elementary matrix. Yeah, so I'll just stop the recording here and then we'll see what else to do.